Today we're going to talk about rational expressions. Let's define rational expressions. Rational expressions have a general form, P over Q. And P and Q both will be polynomials. And that's the general form of a rational expressions. It's essentially just a fraction but with variables. And you could see some examples in example 1 and practice 1. Which you see right here, these are all rational expressions. And as you can see, they're in the fraction form and you have variables on the top and the bottom. Let's start with example 1. Example 1 asks you to determine the value for which each rational expression is undefined. Since a rational expression is just a fraction, it has the same restriction. So your denominator Q is not 0. As a result, if we're looking at the first one, you just need to pay attention to the denominator. Make it 0. So in the first one, denominator is ax. I make it 0. And if you solve this for x, you divide both sides by 8. We obtain that x is 0. So for the first one, when x is 0, the rational expression will be undefined. Let's highlight our answer. Number two, it's still a rational expression, so we're still looking at the denominator, 3n plus 1, and we're going to make it 0. If we solve this for n, we will do subtract 1 from both sides, so you obtain 3n is negative 1, and we divide both sides by 3, n is negative 1/3. When n is negative 1/3, the denominator becomes 0, which makes the rational expression undefined. So that's number 2. Number 3, we have another rational expression. So same as before, we focus on the denominator. Let's make the denominator 0. Okay, so this is the quadratic equation. To solve a quadratic equation, we talk about the zero product property. So we need to factor the left-hand side. And then we can see that there's a square. So to get a square, we will need a and 8. And then for the numbers, since the product is 3 and the middle term is 4a, the only right combination will be plus 1 and plus 3. And we can verify this if you do the outer two terms and the inner two terms. You will obtain 3a plus 1a, and that's 4a. Which is indeed what we need in the middle. So this is the correct way to factor it. We're going to make it 0 and solve for a. And by the zero product property, we make each of the factors 0. So a plus 1 is 0, and then a plus 3 is 0. The first equation yields a is negative 1. Second one, a is negative 3. And for this one, we do have two values that will make this rational expression undefined. When a is negative 1 or negative 3, the denominator becomes 0, which makes the rational expression undefined. Okay, so pause the video and do practice 1. After you finish practice 1, you could check your answers. Meanwhile, I'm going to enter the answers. So please pause the video. Okay, well, I'm going to show you the answers. So for practice 1, number 1, this will be undefined when q is 0. And number 2, this will be undefined when y is negative 2 over 3. Number 3, this one will be undefined when m is negative 3 or 2. Let's move on to the second section. Second section is about simplifying a rational expression, or in other words, simplifying the fraction. To simplify a fraction, the basic idea is that you're going to factor both the top and the bottom, and then you cross out the common factors that you see, which is very similar to how we simplify fractions, right? So let's do an example using just regular fractions, numerical numbers. For example, I have a fraction, let's say 8 over 36, right? I have this fraction. And then when we simplify this normally, we will factor the top and bottom to show the common factor, right? So for example, 8, I could do 4 times 2. And then for the denominator 36, I could do 4 times 9. And because I factor in this way, I see there is a common factor 4. So I can cancel them out. And what's left is just 2 over 9. And that's basically the main idea behind simplifying a rational expression. You factor and cross out the common factors. Let's use example 2 to demonstrate this. We're going to start with the top. The top is definitely a quadratic expression. And we do have a common factor among all of those 3 terms, which is 2. So you could see that the numbers are 2, negative 12, positive 18. We can definitely take out a GCF of 2. So that would be the first step. And then what's left is x squared minus 6xy and plus 9y squared. Okay, and then we're going to move on to the denominator. Denominator, we also have a factor that we can take out. Notice that there are numbers 3, numbers negative 27. The common factor is 3. So I'm going to take out 3 and then write down the left. What's left? So if I divide the original by 3, I got x squared minus 9y squared. Okay, so in the first step, I simply factor out the GCF because that's the first step that you do when you factor an algebraic expression. It's always going to be the GCF, the greatest common factor. Next, we're going to factor what's inside of the parentheses. So for the top, we're going to use the trial and error method that I discussed before. Since it's a second degree expression, we know that it's going to become a product of 2 first degree. And if you look at the x squared, in order to get x squared, we need x and x. And then I'm looking at the last term, which is 9y squared. In order to get 9y squared, a common way to do that will be 3y and 3y, right? So let me write it somewhere here. So 9y squared, there's one way to factor. It's just one of the ways, but I think the first way most people think is probably this one. 3y times 3y. So this is one that we can try, right? And we also notice that in the middle, we have a negative sign. So that means both of these should be negative. And the numbers will be, we could try this 3y first, see if it works. 3y, 3y. So it's basically x minus 3y and x minus 3y. And you could verify this. Let's just verify this. So if I do these two, you get negative 3xy. And then if you do the middle two right here, you also get negative 3xy, right? And if you add these negative 3xy, we get negative 6xy. And as you can see, that is indeed what we need in the middle. So this is the correct way to factor it. And now let's move on to the denominator. The denominator has x squared minus 9y squared. So for this one, you might have a hard time factoring this because it only has 2 terms, right? It's missing like the middle term. If it's missing middle term, you have 2 ways to factor this. Let's write it somewhere else. You have 2 ways to factor this. The first way is you could add the middle term. The middle term will be very similar to what you see on the top. So you simply do a 0 as the coefficient, and then you do x and y, and plus 9y squared. So this expression that I have right here, this expression, I'm simply following the format of the numerator right here, and then I place 0 right here so that the middle term disappears because it's 0 times xy. The benefit of doing this is that I can still factor using the same method. So let's try that. Starting with the starting with, oh yeah, I made a mistake right here. This one should be negative. Negative 9y squared. So I add in middle the plus 0xy. And now let's factor this. To get x squared, it is still x and x. The last term right here now becomes negative 9y squared, right? Negative 9y squared. So that means the two numbers that we pick should have opposite signs. One of them is positive and the other one is negative. And the most common way, if you use what we did before, will be plus 3y and then minus 3y. And you could verify this, see if this is the right way. If we do the outer two terms, we get negative 3xy. If we do the inner two terms, we get 3xy. And then if we add these two terms, as you can see, the coefficients are opposites, we get 0xy. And that is indeed what we need in the middle right here. So this is the correct way to factor the denominator. Let's put that right here. Okay, and now we successfully factored the top and the bottom. We can cross out the common factors. Let's cross out the common factors. So what are the common factors, right? We have x minus 3y, x minus 3y, right? These are a common factor. And nothing else you could factor out. Please don't cross out the x because x, as you can see, is not a factor. X minus 3y is a factor. And this one is x plus 3y, and they're different, so we do not cross them out. Over here, we have 2 and 3. They're also not the same, so we don't cross out. And for the final answer, you simply write down what's left. And I'm going to distribute, or actually, you know, our textbook just kept it like this. So if you just keep your final answer like this, it is acceptable already. So we could just write it like this. Personally, I like to distribute the coefficient outside so that there are no parentheses in the final expression. But I'm just following our textbook. You could just keep whatever the remaining factors are in the expression. And this will be the final simplified rational expression. And remember earlier I talked about factoring the denominator right here. So there is another way that you could factor the denominator, but it does require you to remember a formula. Let me write down the formula right here. So the formula that you need to factor expressions like that is this one. If you have a difference of two perfect squares, a square and b square, and you're subtracting, right? You can do a plus b times a minus b. So this is the formula. And how do you use this formula to factor the expression that we were doing earlier? Let's write down the expression first. It's x squared minus 9y squared, right? So the first thing you need to do is you're going to rewrite this expression so that it becomes a squared minus b squared. And the thing that I'm going to change will be the 9y squared because x squared is already in the form of a squared. For the 9y squared, we will change it to 3y parentheses squared. This is because if you apply what we discussed in L5 exponential properties, you will know that when you square 3y, you will get 9y squared. So this will be the format in a squared minus b squared. And then from there, you could apply the formula that I have right here. It's simply a plus b. A is x, right? B is 3y times a minus b. A is x, b is 3y. So this will be a much quicker way to factor expressions like x squared minus 9y squared. As you can see, this one is the same as what we did before. X plus 3y, x minus 3y. Okay, now you can pause the video and complete practice 2. Okay, so I'm going to give you the answer to practice 2. It's 5x minus 5y over 2x plus 10y. So this is the result if you distribute, but some of you might have a different answer that did not distribute the coefficients. If you did not distribute, your answer should look like this. Let me rewrite this. So it should be 5 parentheses x minus y. That 5 doesn't look good. Let's rewrite the 5. Okay, and then over, for the denominator, it's 2 times x plus 5y. So either one is fine. I'm going to highlight this one because this one is probably what you have. Okay, moving on to example 3. Simplifying this. For example 3, let's start with factoring, right? So this will be the same as before. We factor the top and the bottom. The top is x squared minus 4x minus 5. There's no GCF other than 1. So we're going to go straight to the trial and error. I'm going to start with 2 pair parentheses. And then I'm going to put x and x because the first term is x squared. And then the last term is negative 5. So you're going to factor negative 5. There are not many choices. I also noticed that the middle term is negative 4. So I know one of the numbers is negative 5 and the other one is positive 1. You could try other combinations as long as you check, see if it works. So let's check. The outer two terms get you 1x and the inner two terms gives you negative 5x. And if I add these two, I get negative 4x. And that is what we need in the middle. So this is the right way to factor. Now let's move on to the denominator. Denominator is 25 minus x squared. And I would say this is perfect. Why is that? It's because we just talked about this formula right here, right? And this 25 minus x squared is exactly in this format. Let's rewrite this. 25 minus x squared, it's the same as 5 squared minus x squared. And now this is in the form of a plus b, in the form of a squared minus b squared. So we can apply the formula and then write it right here. 5 plus x times 5 minus x. Okay. And then I'm going to talk about something called the opposite factors. And you might notice that we have something very similar, but not exactly the same, right? So what do you see? You see x minus 5 and you see 5 minus x. They look very similar, but they're not exactly the same. So you could not just cross them out. That's going to be incorrect. Instead, we can analyze, see expressions like this. What are they? What are they? I'm going to put the notes on the right hand side. So there's something called opposite factors. Let's write down the definition. Opposite factor. So what are opposite factor? They are in this form. A minus b and b minus a. And that's what we have right here, right? We have x minus 5 and we have 5 minus x. So they are opposite factors. And if you want to show proofs or demonstrate why they're opposite factors, we could do a division to show you. So if I divide these two factors, a minus b divided by b minus a, right? I'm doing a quotient. I'm going to verify that it is negative 1. So opposite factors are numbers that have opposite signs, basically. So if I do a quotient, I'm supposed to get negative 1. Let's verify this. On the top, it's a minus b. What is b minus a, right? For b minus a, I can first rewrite these two terms. I could do negative a plus b, because subtraction is simply addition of opposite numbers. So it's the same thing as addition. And then for the denominator, I'm going to take out a common factor. So what could be a common factor that we can take out? I can put a 1 right here and then put a 1 right here. So as you can see, there is a common factor of negative 1. We have never talked about negative 1, but -1 can also be a common factor. So I take out -1, and then I divide the original expression by -1. So the first one is -1a. If I divide it by -1, it's just going to be a. And the second one is +1b. If I divide that by -1, I get -1b, which is the same as -b. And now you should be able to see that we have a common factor of a minus b. And you could cross them out. And after you cross them out, we obtain 1 over -1, which is the same as -1. So that's how you know that expressions in form of a minus b and b minus a, they are opposite factors. As a result, if you do cross them out, they become -1. So let's come back to our example right here. I'm going to cross out the opposite factors. You have x minus 5 and 5 minus x. But don't forget that you need to put -1 on the top. You could put -1 on the top or on the bottom because it's simply a sign change. Personally, I prefer to put it on the top, and then the other one just becomes 1, which is the same as -1. All right, and then for the remaining factors, they're not opposite factors, they're not common factors, so we simply keep them. And let's write down the final answer. So on the top, it will be negative, right? And then you have x plus 1. And then for the denominator, it's 5 plus x. And you know me, I like to place the negative sign outside of the fraction. So I'm going to rewrite this as negative. And then notice that for the top and the bottom, if I take out the negative sign, there's just one factor left. If there's just one factor left, we don't need the parentheses. So you could just do x plus 1 and then 5 plus x. And that will be the final answer. Okay, now pause the video and practice 3. Okay, I'm going to give you the answer to practice 3. The answer is negative x plus 2 over x plus 1. That's the answer. All right, moving on to section 3. Section 3 is about multiplying rational expressions. And we're going to do a review of multiplying fractions in example 4 and practice 4. We have been discussing this recently. So in general, when you multiply two fractions, you multiply straight across, right? The numerator multiplying by the numerator, the denominator multiplying by the denominator. But today we're going to talk about a different method. So let's start with copying this expression. 15 over 27 multiplied by 7 over 5. Generally, you just multiply straight across, but that will yield large numbers, and you also need to simplify in most cases. There is a much easier way to multiply fractions without simplifying at the end, which is called factoring. There's no surprise here, right? Algebra factoring is a huge part of it. So let's factor them. The process is very similar to what we just did in section 2. For 15, I'm going to factor it into 5 times 3. And for 27, I'm going to factor into 3 times 9. And then I have the second fraction, 7 over 5. So how do you factor, right, you might ask? Because for certain numbers, there are multiple ways to factor them. The key is to look for other numbers. For example, I noticed that there is a 5 right here. So if I can find a 5 on the top, that would be ideal. And I did notice that 15 has a factor of 5. So that's why I factor 15 into 5 times 3. As a result, I'm able to cross out the common factor, 5. So basically, I call it the factor correspondingly you need to look at numbers in other places and then factor accordingly so that you could show the common factor and cross them out. Do we have any other common factors? We do, right? We have 3. So let's cross that out as well. And now we have 2 numbers left. The top is 7. The bottom is 9. Isn't this nice? If you use this strategy to multiply fractions, your calculation is hugely reduced in terms of the amount of work that you have to do. So personally, this is the method that I prefer. And now let's go ahead and finish practice 4. Pause the video. When you are ready to check your answer, you could restart this video. Okay, so hopefully you got something for your practice 4. The answer is 4/7. Let's highlight these solutions. All right, let's move on to example 5. Example 5 is the real business, right? Because this chapter is about rational expressions. First step, factoring. We need to find the common factors. 5x. So 5x, I'm going to factor into 5 times x. That's pretty straightforward. And then we have the denominator, which is x squared plus 5x plus 6. So I'm going to do trial and error. To get x squared, you're going to do x and x. To get 6, you could do 1 times 6 or 2 times 3. But notice that the middle is 5x. The only way to get the middle 5x will be 2 and 3. And it's positive. So I'm going to do positive 2, positive 3. For the sake of practice, let's just check, see if it's right. The outer 2 terms yields positive 3x. The middle 2 terms yields positive 2x. And if I add these 2 terms, I obtain 5x, which is indeed what's in the middle right here. So our factor is correct. All right, now let's keep factoring the second one. X squared minus 4. So this x squared minus 4 is in the form of a squared minus b squared, right? And because it's in this form, we can apply this formula that we talked about earlier. A squared minus b squared is a plus b times a minus b. So we're going to use that formula and factor this part. X plus 2, x minus 2. And then for the denominator, it's 10x. I'm going to factor into 2 times 5 times x. I did it because there is a 5 on the top, and that's a common factor. Now let's cross out the common factors, which is my favorite part. We have 5 and 5, cross them out. We have x and x, cross them out. We have x plus 2, x plus 2, cross them out. And then we're going to write down what's left. On the top, we have just x minus 2, and it's just one factor, so I can get rid of the parentheses. And then for the denominator, you have to be a little bit careful. We have x plus 3, but we also have 2 right here. If you just follow the textbook, you could just keep them like this. So I'm going to write the number first, and then I have parentheses x plus 3. You could also distribute that 2, multiply it into the parentheses. That is also okay. But for us, this could be the final answer. And now let's pause this video and complete practice 5. When you're ready, you could restart this video and check if your answer is correct. Okay, hopefully you finished this. The answer to this is 3 times x minus 6 divided by x plus 5. You can also distribute that 3 on the top. That will also be correct. Okay, the last section of today is division of rational expressions or division of fractions, right? So division of fractions, if you remember, we use 3 words, right? So it's called invert, and then flip. Let's use example 6 to demonstrate. It will be a quick review of those three words. So example 6 is in the form of a complex fraction. We talked about this when we were doing L5. Complex fraction means you have fraction within fractions. So we have a fraction on the top and we have fraction on the bottom, and there is a whole fraction right here. So that's why it's a complex fraction. If it's a complex fraction, we usually understand it as the division of two fractions. So essentially, this is the same as 15 over 27 divided by 5 over 7, right? And then we can use those three words, keep, invert, flip, to rewrite this expression. Keep means that we're going to keep the first fraction. Invert means we're going to invert the operation from division to the inverse operation. Inverse of division is multiplication. And then we're going to flip the second fraction upside down. So 5 over 7 becomes 7 over 5. And this is now a multiplication of two fractions. And if you remember, this looks very familiar. And that's because we did that earlier in example 4. So see, it's exactly the same problem, right? 15 over 27, 15 over 27 times 7 over 5 times 7 over 5. So we already know the answer. It's going to be the same process. And we found earlier that the answer is 7 over 9. And that's basically how you deal with division of fractions. You convert it to multiplication of the first fraction by the reciprocal of the second fraction. All right, I'd like you to pause the video and complete practice 6. Okay, so practice 6, after you convert it to multiplication, it becomes practice 4, which means the answer is 4 over 7. Example 7. So example 7, now we're doing the real business. Rational expression with variables. So we're going to follow the same way. It's a complex fraction because we have fraction within fraction. I'm going to rewrite this as division of fractions. 5x over x squared plus 5x plus 6, right? Divided by 10x over x squared minus 4. And now it's a division of fractions, so we can use those three words. Keep, invert, flip. Keep the first one, let's copy. Invert the operation from division to multiplication. And we're going to flip the second fraction upside down. And does this look familiar? Yes. So this is again converting the division of fractions to multiplication of fractions. And this one is exactly the same as example 5 right here. We did that. So I'm just going to copy the answer because we did that earlier. It's x minus 2 over 2 times x plus 3. Now pause the video and do practice 7. Okay, so you probably guessed it. It shouldn't take you more than a minute to do practice 7, right? Because this one, first you convert it to division, and then after you convert to division, you use the keep, invert, flip to obtain the multiplication, which is the same as practice 5. So this one is the same as practice 5. That means we could copy the answer. It's 3 times x minus 6 over x plus 5. So as you can see, they're corresponding to each other. The practice 7 is the same as practice 5, just in a different form. Example 7 is the same as example 5. All right, the final two problems will be the last two practices that we're going to do today. Let's do example 8 together. So example A, we added one more rational expression. Now in this expression, we have 3 rational expressions. But the process will be the same. So I'm going to factor as we go, just to save some space. Because we know that for the division part, we're going to flip it, right? We're going to flip it. So let's start with the first part, 4m plus 4. I'm going to factor into 4 times m plus 1, taking out the common factor of 4, over the denominator is 3m minus 15. I'm going to take out a common factor of 3, and this will become 3 times m minus 5. So I completed factoring of the first rational expression. Let's do the second one. Second one on the top, it's m squared minus 3m minus 10. So it's a very typical quadratic expression. We're going to do trial and error to factor this. M squared becomes m and m. Negative 10, so you could try a few different combinations. You should find out that negative 5 and positive 2 would work. This is because if we do the outer 2 terms, we get 2m. If we do the inner 2 terms, we get negative 5m. And if we add them, we get negative 3m. And that negative 3m is what we need in the middle. So this is the right way to factor it. Next, we do the denominator, m squared minus 4m minus 32. Same thing. To get m squared, you have m and m. To get negative 32, we have different ways. But I know that the middle is negative 4m. So after a few tries, or if you know what it is, it's going to be negative 8 and positive 4. And then we can verify, see if it's right. The outer 2 terms gives you 4m, and the inner 2 terms gives you negative 8m. And if you add these 2 terms, we get negative 4m. And that is what's in the middle, so our factor is correct. And then I'm going to flip the last fraction, because here we have a division, so I'm doing invert and flip. If you did flip, I'm going to write it somewhere else. So if I flip this fraction, it will become 6m minus 48 over 12m minus 36. And then I'm going to look at this green expression and factor it. So on the top, I can take out a common factor of 6, and that will give you m minus 8. And then for the denominator, I can take out a 12, and that will give me m minus 3. M minus 3. And I noticed that there are some numbers that I can keep factoring. For example, I can rewrite the 12 as 4 times 3, because I noticed there is a factor of 4 on the top. So I'm going to rewrite this 12 as 4 times 3. And then same thing with the 6 on the top, right? 6, there's a factor of 3 on the bottom. So I'm going to rewrite this 6 as 2 times 3. Okay, and now I'm ready to cross out common factors, which is my personal favorite part. Let's look for common factors. So we have 4 and 4. We have 3 and 3. Anything else? Let's see. We have m minus 5, m minus 5. We have m minus 8, m minus 8. And I think that's everything that we can cross out. Let's write down what's left. On the top, we have one number left, which is 2. And then we have 2 more factors. The first one is m plus 1, and the other one is m plus 2. Don't forget the parentheses. For the denominator, we have one number left, which is 3. And then we have 2 factors that have m plus 4, and m minus 3. All right, and that will be your final answer. Let's highlight that. So you don't need to distribute if you want to save time. This will be accepted as the correct answer. And now let's complete practice 8. So please take your time. This one does look complicated and there are a lot of factorings that you need to do. When you finish, you could restart this video and check if your answer is right. Okay, so hopefully you finished practice 8. I'm going to give you the answers. So the answer will be on the top, it's n plus 5 times n plus 9. And then for the denominator, we have 3 factors. You have the number 2, and then you have n plus 6, and then you have 2n plus 3. So it is definitely a little complicated, but if you take time and complete this, you should be able to get the right answer. All right, and that's this handout, L6. So after you complete this handout, please upload to Brightspace as usual. And enjoy the rest of your day.